All right, guys, today we're kind of expanding on units a little bit more. We're talking about standardized unit systems, which even to this day is still kind of a mess. A long time ago, they used to measure things. There wasn't a standard unit, or in other words, when they said a foot, what they meant was the length of an actual foot. Well, everyone's feet are different lengths, so not everyone had the same measurement when they talked about a foot. Not only that, but an inch was how wide a person's thumb was. And if you had skinny fingers, your inch was a lot smaller than somebody else's inches. So it became a problem that they're starting to try and do business with in all sorts of situations. And because everyone's measurements were different, people were finding ways to take advantage of that. In other words, you use your daughter with little tiny feet to measure out the feet of fabric that you're selling at the store because you're getting more money for her little tiny feet than if you were measuring your great big feet. So some French guy came up with the metric system, and then the US decided that's too easy. Let's make a complicated system of our own. And we still use that today, at least for now. Hopefully that changes. But when you look at our system, there are so many conversions that you have to worry about. For example, when we're talking about lengths, there are 2.54 centimeters in an inch. Well, there's 12 inches in a foot, 3 feet in a yard. There's 6 feet in a fathom if you're dealing with depths at sea, right? There's 5.5 yards in a rod. There's 5,280 feet in a mile. Furlongs are measured by rods, which is 1/8 of a mile. It just gets nonsense. When you look at weight, it's not much better. We have 437.5 grains to an ounce, 16 ounces to a pound, 2,000 pounds to a ton, and then 2,240 pounds to a long ton. And then volumes get just complete nonsense. 3 teaspoons to a tablespoon, but then you go 2 tablespoons to an ounce, then you go 8 ounces to a cup, and then 16 ounces to a pint, and 2 pints to a quart, and 4 quarts. I mean, the numbers just jump all over the place, and it's a lot to keep track of. It's a lot to memorize. Well, how many of this is there in this other measurement? Which makes math problems sometimes a little bit more difficult when you're dealing with these types of units. So for example, if I'm comparing prices, which you're going to have to do on the homework, on the review, on the test, this is a big one here. You're planning to make pesto and you need to buy basil at the grocery store. You can buy a small container that costs you, let's see, $2.99. And that'll get you 2/3 of an ounce in that of if you buy the small container. Or at the farmer's market, you can buy it for $12 for a pound of basil. And it wants to know, well, which is the better deal? I think that that's kind of obvious if you have a sense of weight a little bit, but it's probably going to want us to give them a mathematical proof. So the problem I have is this one's measured in ounces and this one's measured in pounds, and those aren't the same measurement. So it's hard to say, well, which one's a better deal? So what I want to do is I want to convert this one into pounds. So I take my $2.99 and my 2/3 ounces. And what I want to get rid of is the ounces. So when I multiply, I want ounces to go away, which means ounces need to go on top of whatever I'm going to multiply by. And what I want to replace ounces with is pounds. So I want pounds to go on the bottom. So I need something that tells me ounces and something that tells me pounds. And I know that 16 ounces is 1 pound. That's a correct ratio right there. That's not going to change my my numbers here because I'm just multiplying by 1, right? So when I multiply, my ounces cancel out and I get $2.99 on top, well, $2.99 multiplied by 16, the ounces go away. And on the bottom, the ounces went away and I have 2/3 multiplied by 1 pound. So when I multiply that out, 12.99 times 16, and then I'm going to divide it by 2/3 because 2/3 times 1 is just 2/3. I want that to go away. So I do that. 299 times 16 is 47.84. I divide by 2/3 and I get 71.76. So for this little container of basil, I'm paying $71.76 for 1 pound. Clearly, that's a lot more expensive than paying $12 per pound at the farmer's market. I don't know how many people use a pound of basil. I would bet that most are still going to buy the small container just because they're not going to use vast quantities of basil. But I want to compare the two. So if you're going to compare two things, you've got to convert them to the same units. And it's usually easier, not always, but a lot of times it's easier to take the smaller unit and convert it to the big one. We could have gone the other way, but trying to convert $12 per 1 pound into 2/3 ounces, that's just a fraction I don't want to deal with. So French, well, I guess back then, this was the original unit system. They said, all right, this is getting too complicated. Before the US came up with an even more complicated version, they said, we've got to get all of our units to be the same. So they came up with meters are what they use to measure length. So our standard measurement is a meter. And that's usually represented by an M, okay? Kilograms are what we use for mass, and that's abbreviated with kg for kilogram or grams. Seconds are what we use to measure time, and liters are what we use to measure volume. And then to convert from one to the other, he came up with this system where if for example, this table might look a little bit complicated because it skips one thing right here in the middle. You've got 10 to the first, second, third power, and over here we've got 10 to the -1. But right here in the middle is something called 10 to the 0, which is just our standard meter or gram and second and liter. Okay, so 10 to the 0 represents just our standard measurement. But to go bigger, I've got meters, and maybe we'll write these out a little bit different. I've got meters that are 10 to the 0 power. And if I add a deca in front of that and call it a decameter, that is 10 times bigger. That's 10 to the first power. A hecto is 10 to the second power. A kilo, which is one you see a lot, a kilometer or kilometer is 10 to the third power. So it's 3 powers of 10 times bigger than a meter. So it's 10 to the third power bigger, because 10 to the 0, guys, that's just 1, right? And then it keeps going up from there. It also goes down. If to get smaller than meters, we have what is called a decimeter. And that's 10 to the -1 power. So that is 10 times smaller than a meter. A centimeter, you guys know that one, is 10 to the -2 power. That's 100 times smaller than a meter. And it goes on and on and on. We get a millimeter, which is 10 to the -3 power, and it keeps going down. The nice thing about this is to go from centimeters up, all I have to do is multiply by powers of 10, by 10 or 100 or 1,000 or 10,000 or 100,000. I don't have to multiply by 8 or 2/3 or 16 ounces. I just multiply by powers of 10. So to move up, to get bigger, I'm going to multiply by 10 to a bigger power, like 10 to the third or 10 squared. To get smaller, I'm going to multiply by 10 to a negative power, which is really just like dividing by 10 to a power. Remember, if I multiply by 10 to the -3, that's actually 1 over 10 thirds. So I'm dividing by 10 to the third power instead of multiplying. So we use this system in a lot of what we do as far as measurements go. In a lot of places where you use measurements a lot in engineering, in physics, they use these types of measurements. Now, if it's been a while since you've dealt with powers of 10, you might want to pause the video. In fact, you should probably pause the video anyway and just read through this page. If there's anything that you don't remember, add that to your notes. But a lot of this, well, all of this is stuff that you've already learned. It's just a review of some things that you need to know. So pause the video, read this over real quick, write down what you need to, hit play when you're ready to go on. All right, so moving on. We're going to use those metric units to do a couple of different things. We're going to convert 2,759 centimeters. We want to change that into meters. And there's a couple of different ways that I can do that. So part A, I want to take 2,759 centimeters. And I'm going to try really hard to keep track of my units. So I'm going to keep writing them down. I don't want to just put numbers here. And I want to change that into meters. I don't want centimeters anymore. I want to change that into meters. So one way to do that is the way the book showed you for the last unit. I want to get rid of centimeters on the top, which means I need to put centimeters on the bottom and multiply by something. And again, I want to get rid of centimeters and replace it with meters. So what I'm looking for is a comparison of meters and centimeters to put on this side. Okay. And I know, looking back at my metric system, that if I have a meter right here, that's 10 to the 0 power, and a centimeter is 10 to the negative 2 power. So to go from 10 to the negative 2 up to 10 to the 0, we're going up by 2 powers of 10. We're going up by 10 squared, which is 100. So I have 100 centimeters in 1 meter. Okay, I have 100 centimeters in 1 meter. If you can't work your way through that, if you just put the 10 powers on there, like for instance, if I had something like, let's use something a little bit not so nice. Let's use hectometers and millimeters. Millimeters is 10 to the negative 3. Hectometers is 10 squared. So if I had millimeters on bottom and hecto on top, or excuse me, on the bottom, millimeter on top. Hecto was 10 squared. Millimeter was 10 to the negative 3. Those are the same. That right there would multiply out to be 1. Okay, so 1 meter right here over 100 centimeters. My centimeters are going to cancel, and I'm going to end up with 2,759 multiplied by 1 meter on the top. And on the bottom, I'm going to be left with 100, but my units are gone. So really, this is just 2,759 meters divided by 100, which is 27.59 meters. When I divide by 100, it moves my decimal 2 places, and I'm left with meters. Okay, so 2,759 centimeters is the same as 27.59 meters. Now, you could also do this as a proportion, 2,759 centimeters, and I want to change that to meters. So I'm just comparing centimeters and meters. And on this side of the equal sign, I would have to put centimeters on top and meters on bottom. But then I can just cross multiply and divide, and I'm going to end up with the same answer. 27.59 is what's going to be my missing value right there. Either way, you get to the same place, okay? Now, how many nanoseconds are in a microsecond? So I want to know how many nanos are in a micro. And when it asks you something like this, you always want to put the larger unit on top and the smaller unit on the bottom. So nanos and micros. Nanos are 10 to the negative 9. Micros are 10 to the negative 6. So 10 to the negative 6 is bigger. 10 to the negative 9 is smaller, so that's going to go on the bottom. You can plug this in your calculator, or you can use those tricks that you know, because I can move 10 to the 9th on top to get rid of the negative, 10 to the 6th on bottom to get rid of that negative. And then when I cancel stuff out, all I'm left with is 10 to the 3rd power on the top. So it is 10 to the 3rd power. There are 10 to the 3rd nanoseconds in a microsecond, or 1,000 nanos in 1 micro. Larger unit goes on top. Okay? Let's try a couple more. We've got some metric system conversions here. It's not a table that you need to memorize. If this comes up on a test or on the quiz or a review or anything else, if you need to know one of these conversions, it'll give you the table to use. So don't worry about memorizing this. You might want to add it to your notes, but you don't have to count on memory. So it says the marathon running race is about 26.2 miles. How long is that in kilometers? So I want to change miles to kilometers. So I'm looking for miles in kilometers, and I've got them right here. And what it tells me is that 1 mile is the same thing as 1.6093 kilometers. But I don't want 1 mile. I want 26.2 miles. And I want to know how many kilometers that is. So if I'm using proportions, this is how I would set it up. I cross multiply, divide by 1. So what is that? 1.6093 times 26.2. 1.6093 multiplied by 26.2. And technically I divide by 1 because there's a 1 there, but that just gives me the same answer, which was 42.16366. So 42.16366 kilometers is what's missing there. So that would be my answer. You could do it the way the book walked you through last time. I could take 26.2 miles, and I want to get rid of miles. So I need to multiply that by a fraction with the miles on the bottom so that the miles cancel, but I want kilometers on top. So I look for my miles in kilometers, which is right there. 1 mile on the bottom, 1.6093 kilometers on top. The miles cancel, 26.2 multiplied by 1.6093 kilometers, all divided by 1, gives me the exact same answer, okay? Square kilometers to square miles. I like this one. This is a big ACT type question. How many square kilometers are in 1 square mile? Because a lot of times you miss an important thing here, and that's the square, okay? I know that in 1 mile, there is 1.6093 kilometers, but it doesn't want 1 mile. It wants 1 square mile. And if I square the top, I've got to square the bottom. So I get 1 mile squared on the top because 1 squared is just 1. And my kilometers squared on the bottom is 1.6093 squared. So I take 1.6093, square it, and I get 2.589. We can round that to 2.59. Was that the right rounding? 2.59 kilometers squared. Okay, so if it asks you to compare squares, just make sure you square the original comparison for both units. Converting. Again, these are conversions you don't have to memorize. If you need to use them on a test or on the review, on the homework, it will usually give them to you. But this is a temperature conversion table. So it says if I want to go from Celsius to Fahrenheit, then I take the Celsius and I multiply it by 1.8, and then I add 32, and I'm going to end up with Fahrenheit. It also tells me how to go from Fahrenheit to Celsius. I plug in my Fahrenheit temperature, do the math, and I get the Celsius. So let's do a problem. Average human body temperature is 98.6 Fahrenheit. What is that on the Celsius and Kelvin scales. So I got to convert this to Celsius. So if I'm going from Fahrenheit to Celsius, I want to use this one. So I don't know what the Celsius is. That's what I'm looking for. Equals the Fahrenheit, 98.6, minus the 32, divided by the 1.8. And please remember that that top needs to happen first. So 98.6 minus 32, I'm going to put that in parentheses before I divide by 1.8. And I get 37. So that's 37 degrees Celsius. Now it wants me to go from Celsius to Kelvin. So Celsius to Kelvin is this one right here. And you know which one because I know the Celsius and I want to get the equal part, the Kelvin. So I plug it in. Kelvin equals 37 Celsius plus 273.15, which is going to equal what? That's 280, so 310.15 Kelvin. Degrees Kelvin. So make sure you can convert. Again, this is something that you're going to see in some important things in the future. It's a common conversion, so it's one that you need to be comfortable doing, okay? Complete the following sentence with a power of 10 greater than 1. So I just want to know how much bigger one thing is than another thing. So it says that a liter, and I wrote the units right here, a liter is 10 to the 0 power, is how many times as large as a picoliter? Well, a liter is 10 to the 0, and a picoliter is 10 to the negative 12. So if I put the big on top and the little on the bottom, when I simplify 10 to the 0, that's just 1 over 10 to the negative 12. To get rid of the negative, I move this whole thing to the top, so I get 10 to the 12th power. So a liter is 10 to the 12 times as large as a picoliter. That's 10 with 12 zeros after it. That's a lot bigger. Picoliter is a pretty small measurement. So another one, complete the following sentence with a power of 10 bigger than 1. A cubic meter, so 10 to the 0 power, is how much larger than a cubic millimeter? Now be careful because of that word cubic, because I'm not just dealing with 10 to the 0 on top, because I'm dealing with cubic meters. And on the bottom, I put my millimeters because they're smaller. So that's 10 to the negative 3. But I'm also dealing with cubic millimeters. So that becomes 1 to the 3rd power over 10 to the negative 9th power, right? 3 times negative 3 is negative 9, which becomes 1 over 10 to the negative 9th, which to get rid of the negative, I move it up. So that just becomes 10 to the 9th power. So a cubic meter is 10 to the 9th power times larger, or in other words, 10 with 9 zeros times larger than a cubic millimeter, okay? All right, we'll do some more examples in class. If you want to give the homework a try at home, see what you can do.